In this section, we talk about ways of combining functions. And first, we're going to talk about the algebra of functions. What we mean by that is just combining functions via addition, subtraction, multiplication, and division. And the way we do that is pretty straightforward. For example, we create the function f plus g by saying what we're going to mean by f plus g of x is the function that does f of x and also does g of x and then adds them together. If we think in terms of our function machine, that would look something like this. It's got a little copy of function f in there and a little copy of function g. If we put an x into this function, it gets routed into both f and g, and what comes out in here is f of x, what comes out here is g of x, and then what comes out of the addition function is f of x plus g of x. So that's what f plus g does. And the others are similarly straightforward. What we mean by the function f minus g is the function that if you give it x, if you give it any input, what comes out is f of the input minus g of the input. And similarly with multiplication and division. F times g of x is f of x times g of x, and f over g of x is f of x over g of x. So let's see an example, a couple of examples of how this works. Given f of x equals 2 over x and g of x equals 3x, let's find formulas for the function f plus g of x and f times g of x, and then we'll evaluate f plus g of 1. So, f plus g of x, again by definition that means do f of x plus g of x. So we have 2 over x plus 3x. And this is a good time to review a little bit of algebra. What if I want to actually do this addition and combine my two terms into a single rational expression? Well, I'm going to need an LCD for that. So realizing that there's an invisible 1 denominator under the 3x, our LCD is x. So the first fraction already has that denominator. Our second fraction would have to be multiplied by x over x to achieve that denominator. Now we have two things that have the same denominator, so we can add the fractions by adding the numerators and get 2 plus 3x squared over x. What about f times g of x? By definition, that's the function that does f of x times g of x. So 2 over x times 3x. Those x's cancel and leave us just the constant function 6. Last, for f plus g of 1, we actually can do this in two different ways. We could go f of 1 plus g of 1 and say, okay, that's 2 over 1 plus 3 times 1, which gives us 5. Or, since we already have the formula for f plus g, I can simply plug into that formula and say I have 2 plus 3 times 1 squared over 1, and again we get 5. Either of those is equivalent. Let's look at another example. Given f of x equals the square root of 9 minus x squared, and g of x equals the square root of 3 minus x, let's find a formula for the functions f minus g of x and f over g of x. So f minus g of x is defined to be the function that does f of x minus g of x. So that's square root of 9 minus x squared minus the square root of 3 minus x. And continuing on with our review of algebra a little bit, let's recall that we cannot combine square roots via subtraction or addition unless you have the exact same thing inside the square root. So for example, if I have square root of a plus or minus square root of b, that's not going to be the same thing as having a plus or minus b under the square root. So this cannot be simplified. Moving on to f over g of x. By definition, that's the function that does f of x over g of x. So we have square root of 9 minus x squared over the square root of 3 minus x. Now this can actually be simplified because square roots have the property that if you are multiplying or dividing them, they can have different things on the inside and you can still combine the square roots into one. So square root of a times square root of b is the same thing as the square root of a times b. And for this example, what we need to know is that the square root of a over b is the same as the square root of a over the square root of b. So these are some rules for radicals that I'm going to assume you know. So let's go ahead and do that. Combining these into a single square root, we have 9 minus x squared over 3 minus x. And that numerator factors as 3 minus x times 3 plus x. So we've got a factor that will cancel out our denominator and leave us a final answer, square root of 3 plus x. While we're talking about square roots, maybe I should mention one more thing here. It's tempting to think that you can simplify 9 minus x squared by going square root of 9 minus square root of x squared, but that's covered by this property that we cannot split up a square root sign across a plus or a minus. So another way to say that is that if you're doing the square root of a squared plus b squared, that's not going to be equal to a plus b. And similarly, square root of a squared minus b squared is not equal to a minus b. So square roots just don't work nicely with addition and subtraction. They do work nicely with multiplication and division.